6.2, radicals and rationals. Quick reminder here. Today you're going to be solving a lot of problems that that don't look like this, but are this. In other words, we're looking for a number x such that that number, when I multiply by itself 3 times, I get negative 27. We can do this in our calculator. We can also do this in our brain. So if you start and think about it for a moment, what number times itself 3 times is 27? So let's try, for example, 5. Well, if I take 5 and I multiply by itself 3 times, I actually get 125. So that was not even close. That was too big. If I go smaller, like 2 times 2 times 2, that's too small because that's only 8. So we guess 3. And now we can see that, oh yeah, 3 does give me 27. But I need negative 27. So my answer will be negative 3, because if I multiply 3 negatives, then I get a negative 27. All right? The way that you write this out is we would say, I'm going to take the, not square root, but the third root of radical negative 27, that equals negative 3. So this is kind of the notation that we'll be writing out. Hopefully you know how to do that on your calculator as well. So here we go. Item number 1. Here is a radical sign. And in this case here, when you put an n there, you're going to drop the square part of your answer, the way you would read that, and we would say just the root. Okay, so a radical can be called a root. Just don't call it a square root anymore, because that's not what we're dealing with anymore. All right, again, this is the radical sign, or you can call it the root sign. Finally, what is the index? So we have a radical and an index. An index is the n. That's that number that goes right here. Up to now, when we've done things like what is the square root of 16, and we say 4, we haven't written it, but there's been an implied 2 there. So this then would be the second root of 16 is 4. All right, first example. Simplify and rewrite. First off, you have to recognize this is in what we call radical form. I'm going to write this now in what we call rational form. The problem below that you can see is written in rational form. That is, our exponent is a ratio, and I need to write that using a radical sign. So these two problems are kind of doing the opposite things. Problem number 1. There's 2 numbers that are hiding. There's a 1 here, a power. It always has a power of 1 if there is no power there. And then because this is the square root, we usually leave the 2 off. So it's important that you see those 2 numbers, because that's the 2 numbers that you use in your ratio. Okay, so we're going to take 25 to the 1/2 power. Again, hopefully you know what the square root of 25 is. What number times itself 2 times is 25. And you can see that that would be 5. All right, example B. What is the 125 to the 2/3 power? And I'm going to rewrite that again, first of all, in radical notation. And we put the number here, 125. Here I put the index of 3, and here I put the power of 2. A couple pieces of advice is, as you do problems like this, always do the index first and do the power second. Okay? So the problem as I'm going to do it is, what is the cube root of 125? And then I'm going to take that whole thing to the second power. All right, what number times itself 3 times is 125? That is 5. You may have seen that previously in the reminder that I did. 5 times 5 times 5 is 125. So now I need to take 5 to the second power. And 5 to the second power is 25. So there's my answer. In both cases, I've got answers, and we've just rewritten them and just shown how they can be thought of in a different way. All right. Example 2. Find the nth root of a. Keywords, phrases here. The nth root of a. So notice here we've got an n and an a. So I'm going to write this out as a root first of all. A goes inside, and the nth root goes here. And so now I need to find what number times itself 4 times is 16. Yeah? So this is what I'm thinking in my brain. And hopefully you can try a few numbers and hopefully end up and realize that 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is 2. Circle your answer. Now we're asking for the third root of negative 8. So again, I'm going to write the 3 on the outside of the radical sign, and I'll put the negative 8 on the inside. Again, what number times itself 3 times is negative 8? Well, clearly 2 times 2 times 2 is negative 8. 8, and then to get the negative, all we need to do is slap that negative sign on. So the answer here is negative 2. Again, we rewrote it as a radical, and then I evaluated it. All right, finally, or next to last, rewrite and evaluate. So this was like our first example. Again, write the 81, put the power there, right? And then this becomes your index outside. Again, always work on the index first. So what number times itself 3 times is 81, or 4 times. And hopefully you can see that that would be 3, because 3 times 3 times 3 would be 9 times 9. And 9 times 9, last time I checked, is 81. So I'm going to take 3, and again I got to carry that to the first power, which is just 3. Again, this is in radical form. I'm going to write this in rational form. So I put 8, and then I carry this to the, again, there's an implied 1 there, so 1 over 3. Now I can't forget about that negative sign. I'm going to just flap that in front. Again, this is asking me what number times itself 3 times is 8. And hopefully you can see that that would be negative, or positive, pardon me, 2. Okay, 2 times 2 times 2 is 8. All right. Again, 2 to the first power is just 2. If I put a negative on it, then my answer will be negative 2. Yes? Finally, we'll do an example in class involving Coke and inflation rates. I'm going to pick a couple of numbers here. In 1970, I'll say the Coke can of Coke was 25 cents. Or a bottle of Coke probably then, because they may not have had cans. I would say currently if you go out and buy yourself a can of Coke from a vending machine, you probably spend about $1. All right. there's a formula to calculate inflation rate. And the inflation rate is like how much are things more expensive every year. So I'm going to take the rate is equal to the final cost, which would be 100 pennies over 25 pennies. And it would be 1 over n. And n is the number of years that have transpired. And we can see that this would be 50 years. And we're going to do this on a calculator. I have no idea what the answer to that is, but 4 to the 1/50th power, which is the 50th root of 4. And then from that, I have to subtract 1. I can't forget that. Yeah? So we subtract 1 in both cases. All right. Well, again, I don't have a calculator on me handy, so I can't calculate that